আচ্ছা, আমরা শুরু করতে হবে। Hello and welcome everyone. We are excited to have you join us today for what's said to be an insightful session. It's a pleasure to bring you this webinar, and we are glad to feature Saurabh, one of our finest engineers on the KubeDB team. He has been on this team for an extended period of time. Also, we encourage your interaction. So if you have any questions, don't hold back. Drop them in the Zoom chat anytime, and we will address them during the Q&A segment of the webinar. Let's jump right in. I'm passing it over to Saurabh, who will get us started. Hi, Saurabh.
Let me share my screen real quick. Hello, good people. Welcome to you all. I am Saurabh Chandra Biswas, currently working as a senior software engineer at Appscore INC. So today I'll be talking about how you can manage KubeDB databases at scale using Operator Shard Manager. So let's just get started with the contents that we'll be discussing later on. So first of all, I'll be discussing about what is the problem that we face at scale, and then later I will discuss about Operator Shard Manager, what is it, and how we can solve the problem that occur at scale. And later I will be showing a demo of doing that. So if you are using KubeDB and you have maybe 10 to 20 or maybe 30 databases running, then it's really quite fine to have that much databases. But this is quite of a problem when you kind of have lots of databases, maybe hundreds or thousand databases, right? Because all the databases are kind of managed by a single pod, right? So if you have maybe hundreds or thousands of databases, then what is going to happen? All of those databases are kind of running, and we need to consistently and persistently check the health of the databases. So that kind of take lots of load on a single pod, eventually in a single node, as we are kind of only have a single pod for now, right? So to kind of solve this problem, we kind of introduced Operator Shard Manager. Also, it was quite tough to debug those type of problems. So also as it has only a single pod, so there isn't any high availability up till now. So basically, Operator Shard Manager is a custom controller, Kubernetes custom controller, which will distribute your resources to its corresponding controllers, and it will use consistent hashing to do so. And we will see all of them in upcoming slides. So this will also reduce the volume of API call that it is currently making. When you have lots of databases, then there will be lots of API calls going through the pods. So also, as we are now introducing operator sharding, which will shard the operators, that means we will have more pods, and more pods means debugging will be quite easier. Also, we will now be able to provide the high availability. So I will discuss quickly how we are going to do that. So, I am kind of assuming that you have at least used KubeDB, and you have, running KubeDB databases on your cluster. So what now we're going to do, we are kind of currently create a shared configuration here where we will describe that we want to manage Postgres custom resource, and the controller for that Postgres custom resource are these provisioner operators. So we have basically 3 shards running. Instead of running a single shard, we now have 3 shard. Okay, so So basically, when you create a shard configuration custom resource object, the operator shard manager controller will watch that part. Okay, so after that, you will create a Postgres custom resource. So that Postgres custom resource will be watched by both the operator shard manager and our KubeDB Provisioner. So when you create a Postgres custom resource, operator shard manager will attach update a label, okay, label on that custom resource. So what will happen that then all the shard manager objects, shard manager pod will um, you know we will see that Postgres object and we'll try to match the shard label that is being set by operator shard manager. And if that shard manager label kind of match with the Postgres CR label, only then uh, that particular pod will provision these Postgres CR. Now, suppose this kind of set this Postgres resource as label shard 0. So that the give me a second. Sorry for the interruption. So once this part is done, that means a label has been attached to this particular custom resource. That particular label related pod will be only responsible for running this particular custom resource. So now I will discuss about thing which is I earlier talked about consistent hashing part. So suppose we have KubeDB Provisioner and its replica is 3, right? So it has 3 shards like shard 0, shard on, shard 2. So there are 3 shards. This is basically 3 controller for running, and let's say we have 3 Postgres custom resource. So let's call them PG on, PG2, and PG3, and you can see that namespaces is kind of different. So what operator shard manager will do, it will see that there is 3 node. I will call them each of them a single node. So a single node, single node, single node. So 3 single node. So what it will do, it will kind of create a hash ring. You see, hash ring, and then it will kind of and then it will map those particular nodes into this hash ring. So we have shard 0 mapped here, shard on mapped here in the ring, and shard 2 mapped here in the ring. Yeah? Okay. So now you just apply a Postgres custom resource. And how you do that? Maybe you just use kubectl apply. Okay. So now you kind of created this particular custom resource. So I will take what it will do, it will kind of take the namespace and name and make a string with it, and then it will hash that particular string, and that hash will eventually reside in this hash string. So for this purpose, for understanding purpose, let's suppose this kind of got placed here, right? So once it placed here, it will try to move clockwise, right? So clockwise, if it moves clockwise, which node it is getting first? This one, right? Shard on. So that means that operator shard manager will attach a label to this particular custom resource saying shard on. So once this label is set, this particular shard on will see that it has a label that matches the name of this pod. So then it will start processing this particular custom resource. Now notice that it doesn't match with this particular one and this particular one, so they will basically ignore this particular resource, right? So now suppose you created another resource whose name is pg2 and namespace is stays. Okay, so our operator shard manager will kind of take this two part and hash it, like stays and pg2, and hash it. And suppose this hash kind of resides this particular area of that hash ring. So again, we will move clockwise, and then we find shard 2, right? So that means this one, right? So then operator shard manager will update for this particular resource a label with this name shard 2. So that means now shard 2 will see this particular resource has the label calling shard 2. So it will then kind of pick up this resource and start processing. Okay. So similarly for this one, it will let's say it placed here, so it will be processed by shard 0. So this is how things are going to be happening. So suppose if you want to modify this on again and apply it again, it will be kind of placed to this on forever. I mean, unless you delete this particular pod, it will be always placed to this this node, which is shard on this one. Okay. So now, yeah, now I will show the demo. So basically, let me show something. I have already installed KubeDB. So I think it will be better if I kind of install it again and then show you something. Okay, forget about that. So I have installed the KubeDB. I will give you the command, and let me show you the command once again. So get install KubeDB. So you see that this is the command basically I have used for installing KubeDB. Here this parameter will be basically the version that we will be using, and which is this particular version. So we are currently using this particular version. And let me show you. You can see we basically have 3 provisioner for running, and if you install any other version, you will see that there is only a single provisioner pod that they are running. But for now, if you see this particular part, KubeDB Provisioner replica count is set to 3. Okay, and you will also you will also need to mention this particular part, which is operator shard manager enabled to true. Okay, so if you enable this, then what will happen? We will have a pod pod with the name shard manager. It should be there. Yeah, so it is in the KubeDB namespace. You see, this is the basically particular pod that I was talking about. If I get back to this part again. So this is this pod, which was kind of managing this type of things. So this is running, and this was installed because I set this particular flag for shard manager enable to true. And if you kind of just increase that replica count to 3 instead of on, and then you will have a resource called shard configuration with this name. Okay. So the controller for this particular resource is this on, right? So if I just quickly go over these fields, what these fields are, what these fields really means, these fields means that the controller. Okay, so what controller? Let me get back to the So this is the controller KubeDB Provisioner, and you have set the replicas to 3. So you have on 2 and 3 replicas. Okay, and this part is the resources. Okay, the resources that this particular controller will look for, like KubeDB.com. I mean, if I get the Postgres resource, you see this is kind of belong to the KubeDB.com group, and this group is in here. So if I create this particular resource, then our shard configuration controller will be keeping an eye on this particular group resources. So if any of the resource belonging to these groups created, okay, so it will kind of just look for the controllers. Yeah, you see there in the first part here, you just mention the name and namespace and kind of IP group of a particular controller, and it will kind of using this particular information, it will get all the ports available running this particular controller. So we have 3 controller running on now. So now I think we can get back to the demo. You see, I have run a command which will show us which are the particular controller running on currently, like 0, 1, and 2. Now, if I create a particular Postgres object, let's say, let me show you the YAML part. So you see, this is kind of just a simple OML. I am taking this replicas 3, and these are the various things that you can look onto our top. Okay, so let me quickly open a few of the logs. So this is the log from Provisioner 0, right? The first controller. There are 3 controllers, 1, 2, and 3. So this is the log from first controller. Okay, and let's say I will open another. So whenever I am going to create that particular Postgres object, it will be assigned randomly but percentagely. Okay, so whenever I will create it, you will see that there will be a label coming here, and that particular label will kind of match with this particular port name, and that result will be basically picked by the particular controller. So let's just apply this. Yeah, you see, we have got a label. This particular label is assigned by our operator shard manager controller, right? So you see the label is, it is saying KubeDB Provisioner ID is 0. So this one, right? This one has the ID 0, ID 0. This ID is 0th index, first index, and the second index. This is the ID. Okay. So now if I see the logs from this particular one, you see, you see this SA Postgres has been picked by this particular port, which is, you see, this one 0. This is missing 0, and here it is 0, right? So this is kind of working, right? But you see, there is no this particular controller is not processing our SA Postgres object, right? This is only being processed by this particular controller. Now you can see that our database is in ready state. Now let's create another Postgres. pg.yaml. So now, now you see this is now assigned to the first index. What is the first index here? This one is the first index. So this particular Postgres object PG is assigned to this particular controller. So you see validating, it is saying the name is PG, right? The name is PG, but it is not processing that is a Postgres, right? So this is the kind of thing where we are now being able to do it. So the best part is you can set affinity rules on node selector to assign this particular controller. I mean this particular controller to a specific node, this one to another specific node, and this is kind of same. Yeah. So now what is happening? All the health check stuff that is running inside this particular controller, it doesn't even bother with this one, right? So this one is kind of managed by this one. So now we are currently being able to shard our operators and run databases on these sharded Postgres objects. Okay, so so now if we kind of just delete any of the ports from any of the controllers, let's say I will delete this particular controller. this is deleted, but once it is okay, so we didn't have any running any controller any Postgres running on this particular controller. So maybe we can just try creating another. Okay. Forget about that. Let's just delete this part on this one. You see that? You see that this particular Postgres is again included by this particular provisioner port. So this is now working. And if we create another Postgres, let's just copy the existing Postgres. Let's say abc dot let's change the name. Let's say abc. Okay. So now you see this particular ABC has been assigned to first port. Okay, first port means this one, right? This is the 0 index on index, and this is the second index. So you see this is currently managing by this one, right? So this is okay. Well, this is all I wanted to show. And let me show you something else also. If I just delete the ports, is a push case 0. Let's say we deleted the push case 0. So let's see if this part pick up my deletion part. Yeah, you see that this part is only managed by this particular column. No events here, right? And we wanted that, right? Because we were kind of having problem when there were lots of Postgres running and a single pod needed to do this health check stuff. Okay, so I think that's all from my part. Yeah, so that now database is ready. Okay. So I have given those commands here. Okay. So now I'll be moving to question and answer session. So do we have any questions?
So our attendees, if you have any questions, you can ask in the Zoom chat, or maybe you can raise your voice. We are open to your questions. So I guess there is no question at this point. So thanks, Saurabh, for your wonderful webinar with hands-on demo. And that wraps up our today's webinar.
Okay, thank you all.
Yeah, a big thanks to each of you for being here and contributing to this session. We are excited to continue this conversation in our upcoming events. Be sure to check out at appscode.com/webinar to explore our full webinar lineup, and I mean, you can join our webinars through that session. So that's all for today's webinar. See you in the next webinar, and have a great day. Bye bye.